Hi, my name is Sangbae. I'm a professor in mechanical engineering at MIT. We are here to show you our latest development of Cheetah. Before showing the real robot, my students are preparing the robot to bring out to show some tricks. We actually developed the previous one, which we love to demo, but the stage is too small. So we'd like to queue up the video. Can you queue up the video of the Cheetah too? So you listened Gil Pratt's conversation. He actually was the DARPA manager who funded this project. At that time, this was the first electric machine that can run and jump. There are a lot of robots that can walk on the electric machine, but this is probably the fastest running machine using electric motor. So efficiency is like as good as an animal. Now the new one I'm showing you is actually exceeding animals' efficiency. This is all custom-built electric motor, electric driver, and most of the things you see is actually blind control. This motion is actually not blind. Actually, using the LiDAR, laser sensor, scan the ground and obstacle. Once you see the obstacle, adjust a step, and then it can automatically create the controller to jump over the obstacle. And the reason why it cannot jump that much because it can actually jump higher. It can jump about a meter higher, but it cannot land. So landing is much harder than jumping. Oh, jumping is amazing. Jumping took like an hour to figure out. The landing took like months to really make it happen. Because we think it's easy because we are doing so easily, but actually programming all this behavior that we are actually doing subconsciously is actually much harder. So let's fire up the Cheetah 3, which is going to be much more mild, much more behavior, so we can actually demo here. So,
kitty.
All right, while they're preparing, I will explain the difference between Cheetah 2 and Cheetah 3. Cheetah 2, we are still experimental platform. We're trying to exploit the dynamics and our control algorithm. It looks awesome. Like now you can't go anywhere. Actually, Cheetah 2 can only do that. Cannot walk, cannot turn quickly. So we developed a new version. It can do actually a lot more. Whoa, it's about to stand up. Uh-oh. It doesn't feel good today?
So that's something to think about, actually. How badly did you feel in your heart when you just saw that happen?
All right. The stance is a little wide, but you should be able to stand up.
Come on, buddy.
So it is very slow, but actually it's twice, each joints are twice stronger than previous Cheetah. So imagine previous Cheetah can jump about a meter height. This one, I don't know how much it's going to jump. Come out, kitty. This is only 2 months old, so our algorithm is very premature. So we're going to show you something else later this year. So today we're going to show you just only a few things we can do very safely. So great.
Tell me about the decision to put eyes on it.
This is an undergrad project I actually see the first time today, so I don't know. I don't know what it's doing, actually.
Messing with our emotions.
It looks like it's looking around you. I have no idea.
Can I ride it?
So it is commanded by graduate student, commanding the body position, and then it automatically calculates how much force I need to generate in each limb so that it doesn't slip or it doesn't fall. You can do a lot more aggressive, but we're trying to be a little careful. Okay, so maybe we should do some Alexa command. So you might notice that there's actually echo. So Alexa, open Cheetah.
I'm the MIT Cheetah.
Cheetah, are you a robot?
Robotic Cheetah in town.
Cheetah, are you a human? Whoa, maybe not. Cheetah, where were you born?
Cheetah obeys. Did I do a good job pawing?
I think it's actually asked you to give me a paw. Cheetah, how old are you? Alexa, open Cheetah.
I'm the MIT Cheetah.
Cheetah, how old are you?
I'm only 4 months old.
Cheetah, are you happy?
Yes. I'm very happy to be here at TechCrunch.
All right, cheetah, wiggle.
Feeling that.
Cheetah obeys. Did I do a good job wiggling?
Absolutely.
Cheetah, go forward.
Try asking me questions.
Oh,
I
okay,
also
sure.
know some tricks.
Can it jump over me if I lay down?
We can, but we're not going to do that today. Yeah. You want the knee flip? Yeah.
Okay, I'm gonna back away. If you guys are gonna try flips, I'm moving.
So this is we're moving away from bio inspiration and then trying to be more practical in the future. So are you going to do manually? Yeah. Let's show how the configuration can change. So this robot is actually there's no front or back or top or bottom. So knee can be reconfigured for the best for the situation. Like if you climb down stairs, you want to knee forward, and vice versa. So we can do a lot of different things because the range of motion is much bigger than Cheetah 2. We can do the same thing. Maybe do spin. Do you want to do manually? Okay, Alexa, open Cheetah.
I'm the MIT cheetah.
We know.
Cheetah, spin. So you can see the range of motion you can do. Let's actually do a little more, but we're trying to be a little careful today. So as you can see, you can do a lot accurate position control, and then now we're going to add a camera. We can move around indoors. And as soon as we're done, we're going to go outside and then jump up and down. So that will be it for the
So
demo.
what's the
Yeah.
near? Oh my God, my mic is turned way up for Cheetah. What's the near-term application for this?
So, our lab members are all fired up to really save lives in the dangerous situation. Like, let's say there's a fire or a high radiation, nobody can get in even. So we're going to send a robot and then check if there's people are inside. But before doing all that, for the short-term goal will be sending robot where we don't want to send a human at all, even though it's not so dangerous. For example, toxic area or mildly radiation area, like the power plant, where the radiation is not detrimental, but those you don't want to pile up on your dose. So actually, there's many applications we can actually send the robot. But currently, the leg locomotion is not really mature yet. So we're trying to make this robot can go anywhere human can access.
So how long till it's untethered?
So these tethers are actually just for safety. A lot of Wi-Fi issue here, so we're actually using wired. But eventually, well, we can actually do it now, but I just want to make sure. So wireless is not an issue. But I think in real disaster situation, I wouldn't use Wi-Fi. There's no Wi-Fi in the building on fire or in the radiation building. So the untether is not an issue. You need to develop more algorithms. For example, can this guy jump down the stage or jump up the stage? The perception has to be better. Right now, it doesn't have a camera. The camera should give you all the geometry, so the leg should be planned properly.
I see eyes.
Those are just
I'm
cartoon
joking.
eyes.
I'm
Yes,
joking
yes.
with you.
Yeah. So
You got more tricks?
what can we do?
We've got a minute 23, and you guys like the tricks, right?
You want to stretch? Alexa, open Cheetah.
I am the MIT cheetah.
Whoa, that's a manual stretch. Did it open?
It said,
Yeah, I think this is a stretch, the manually controlled. Oh.
You mean I heard you before you said it?
Yeah, let's fix the leg. So, what is it twisting? Oh, this is still twisting, still stretching the muscle.
Yeah, a little sore.
That's really slow stretch.
Shy. He's shy. So, do you actually think of it as a gendered thing? Like, is it a she or a he in your mind? Or just cheetah?
Not really. Yeah, we just.
I don't believe you.
Let's talk when you came to our lab. All right? Do you want to flip the knee and go back? No.
I'm actually in pain just seeing the legs like that anyway.
So you might feel kind of some weird sensation, but you know, the building machine that look like an animal is one thing, but in practicality, there's so many reasons we shouldn't copy nature. One of the main reasons is the difference between muscle and electric motors. We have a 200 muscle. We can't really put 200 motors here. We have only 12. That's why we're so focusing on the range of motion so much. So with the 12-degree freedom, we need to be able to maximize the workspace so that we can cover things enough. Want to go backward, maybe?
Tell them to follow me.
All right, so the show is almost over, so try to go home.